Assalamualaikum and hi everyone. Today, me Shafika will talk about power and torque in induction motor. As the induction motors are self-started motors, their powers and torque relations are significantly dissimilar from the associations in the synchronous motor. Its input supply is a three-phase induction motor. In case of normal transformer, the yield of electrical power gained from the secondary part of the transformer. But in case of motor secondary part or rotor, is short-circuit at its end point, so its output is mechanical power. Next, we will see the power in induction motor. The input supply provided to the induction motor. After supplying input to the stator of motor, we have to face some losses in power at the stator which known as a copper losses. Some parts of input power also lost in the shape of hysteresis losses and eddy current loss in the starting part of the motor. The residual power will have to transported to the rotor the of the motor crossing the air gap among the stator and the rotor. This power is named as the air gap power of the motor. The remaining power which transported to the rotor after removal of copper losses is converted to the mechanical power at the rotor. After this power loss due to friction, windage loss and stirring losses, the remaining power we get at output is called output power of the motor. For the features of core losses where there are not in the motor is slightly random. These losses of the motor exist half at the stator part and half at the rotor side. Meanwhile, an induction motor generally works at speed nearly synchronous speed. The comparative rotation of the fields above the rotor casing is rather sluggish, and the rotor core losses are small associated with the core losses at starting part of the rotor, as the main portion of the core losses obtained from the starting part of the motor. Due to this cause, core losses are pointed at the location in the power diagram. The other losses, which are stray, windage, and friction, depend on the speed of the motor. The larger the speed, the greater these losses. But if the motor speed almost equal or approach the synchronous speed, then core losses will have less value. So these three classes of losses are occasionally taken together and named as rotational losses. The entire rotating losses of a motor are frequently measured to be continuous, with altering the speed. Meanwhile, the constituent losses alteration in conflicting directions with an alteration in speed. This is the power stages in an induction motor. Next, we will see the torque in induction motor. Induced torque in a motor explained as the torque produced by the interior electrical to mechanical power transformation. This torque varies from the torque actually obtainable at the points of the motor by a quantity identical to the friction and windage torques in the motor. The value of torque is defined as follows. This torque is known as the induced torque in the motor. The above given equation of torque can also be defined in the shape of slip and power gap losses. This equation is particularly very valuable as it explains the induced torque in form of air gap power and synchronous speed, which does not fluctuate. Information of consequently straight harvest. That's all from me. Thank you.